Welcome. In this video, we're continuing our discussion on area of regions that's bounded between curves, and we're segueing from irregular overlaps to multiple overlaps. So let's consider this function, f of x equals cosine of x and g of x equals sine x. What is the area bounded by these curves between x equals 0 and x equals pi over 2? So please take a moment on your own and graph this either manually or using technology. You'll need to pause the video in order to do this. Okay, you should have a sketch that looks like mine, and I really only sketched the necessary region that's from 0 to pi over 2. And let's go ahead and mark the area we're interested in. So that's what we're actually interested in. If you notice, this means we have region 1 and region 2. And now what's left to figure out is where do these intersect? So take a moment and see if you can figure this out. You should have this memorized from either your pre-calculus course or your trigonometry course. Okay, this intersection is at pi over 4, and this point here is pi over 4, comma, root 2 over 2. Now let's go ahead and set up the integral for our area. Area 1, and that's the area of region 1, and that's equal to the integral. And now before I go on, let's consider a representative rectangle. Am I going to draw my rectangle in this direction or in this direction? If you said it was the latter vertical direction, you're correct. My representative rectangle, and actually let me sketch it somewhere else so I don't block the name of the region, should look like that. And its base here is parallel to the x-axis, so we're going to integrate with respect to x. And the same goes for the other region. So now let's set up this integral, and we're going from 0 to pi over 4. And on top we have cosine x, and on the bottom, and again, top, here you are, there's the top of your head. Hi world, that's you. And so the top of your head, if we come down from the top first to your feet, so again, head to feet, we touch the orange curve, cosine x first, then the purple curve, sine x. So this is cosine x minus sine x dx. And now let's discuss the area of region 2. That's the integral from pi over 4 to pi over 2. And now if we're going from top to bottom, we have sine x minus cosine x dx. So I could integrate both of these and add them together, but what do you think would be a better idea? See if you can figure that out. If you notice, this area here, by symmetry, is equal to this area here. So the total area is just equal to 2 times the integral from 0 to pi over 4 of cosine x minus sine x dx. Integrating, we end up with 2 times sine x plus cosine x from 0 to pi over 4. So this is 2 times sine of pi over 4 plus cosine of pi over 4 minus sine 0 minus cosine of 0. So this is 2 times root 2 over 2 plus root 2 over 2 minus 0 minus 1. This is 2 root 2 minus 2. I hope this video was helpful.